Thank you for being here today and giving me your time. My name is Jeremy Stevenson. I'm from Formulatrix. We are the world leader in automated protein crystallization solutions. So today I want this presentation to be for you. So if I'm going too slow or too fast, please interrupt me and let me know. I want to make best use of your time. From what I understand, you want me to present our entire automation solution focused around RockMaker. And we're going to talk about our imaging products at a later date. Is that what everybody wants to see? Yes? Okay. All right. So let me get quickly started with an introduction to the company. So Formulatrix, we started in 2002. And since then, we've worked very hard to get a bunch of customers. And you'll notice that we have 8 of the top 10 pharmaceutical customers have standardized on RockMaker as their standard for protein crystallization automation. That includes Pfizer, Boehringer Ingelheim, Amgen, GSK. Just this last year, AstraZeneca. Their equipment was getting old. They evaluated all the solutions available on the market, and they decided ours was the best and chose us also. We also have a lot of leading academic customers like the Oxford Protein Production Facility, Karolinska Institute, and if you've seen a lot of the membrane protein work that's been going on recently, Vadim Cherzov at the Scripps Research Institute crystallized a membrane protein. He did that using our equipment. So just to give you an idea of the resources Formulatrix is bringing to this market, we have our headquarters in Waltham, Mass, with about 25 employees based there, a combination of support, and that's where the company headquarters is. We have an office in Amsterdam to cover Europe. We have a software team in Pakistan, where we have about 12 people. About 10 of those are software engineers. They're dedicated full-time just to developing RockMaker. So we have a full-time staff of 10 people focused just on RockMaker. And I'd venture to say that's much more resources than anybody else in the market is investing in protein crystallization software. In addition to that, we have a facility in Indonesia where we do our manufacturing of our equipment, plus additional research and development and additional software development. We have an additional 6 software engineers in Indonesia, about 20 mechanical engineers, and the remainder of that is assembly and manufacturing staff. Okay. So a quick overview of the protein crystallography products from Formulatrix. We start out with RockMaker. That's sort of the brains of our solution. It's the software where you design your experiments, tracks all of your information, pulls in images, drives the different liquid handlers to dispense your experiments. RockImager is our solution for incubating and storing your plates and imaging them. Formulator is our liquid handler for dispensing well solutions. So, and Drop Setter product becoming available this year is available for setting up drops. Okay, so quick overview of how RockMaker works. You start off at your desktop or at any computer doing your experiment design. That experiment design gets stored in a central database server. Then we can drive different liquid handlers to set up that experiment. Then we work with imaging systems to image the results of those experiments. Those images are linked to your original experiment design on your server. And then back at your desktop, you can view and score those images. And you can then also iterate, and we have a cool tool for iterating from when you get some hits to optimizing your next generation of experiment design. Okay. So some features and benefits for RockMaker when we developed it. One, we tried to make it user-friendly and complete. So it's easy to use. It automates the entire crystallization process. Second is we work to make it robot independent. So that's really important. We don't want you stuck with just our solution. We want you to be able to choose the robots that are best for you. And that may mean you have some robots already that we can integrate with, or in the future you'll get different robotics that you'll want our system to work with. We've actually developed drivers for Hamilton liquid handlers, TKN liquid handlers, imagers from Diversified Scientific, Nexus Biosystem, which creates the crystal farm, Tritech, and Rigaku. And also we've made the software robust and scalable. So you can have one user with no automation just using Rockmaker on your desktop, or you can have multiple users and multiple robots using the software. And we've spent the time to make sure that the system scales to handle that performance. Okay, so let me actually jump to now a live demo of Rockmaker. So this is Rockmaker. It may, hopefully, the interface looks familiar to you in that you start out with a folder view of the interface. And the first folder you encounter is a setup folder. So there you'd set up the different containers you'd work with, so the different crystallization plates and deep well containers you're going to work with. Next, you set up all of the different ingredients you want to work with. And it's important to point out that Rockmaker already has all of the ingredients from all of the commercial crystallization screens from the major vendors already entered in, so you don't have to go through the pain of entering those. And if I was to just scroll down here to a precipitant, I'll just give you some information about, so let's go to ammonium iodide. So you can see ammonium iodide can be a salt or a precipitant. We can identify it by a particular CAS number. So ingredients have something which we call stocks, and that's that ingredient used at a particular concentration from a particular vendor. And so there's a stock you can get from Qiagen, which is Qiagen part number 133017, and that's 1 molar ammonium iodide. Jetta Biosciences also offers a stock of 2 molar. Okay? Yeah. And then if you go look at buffers, and let me go to trisodium citrate. Okay. So trisodium citrate can actually be a salt, precipitant, buffer, or additive, depending on how you're using it. You'll notice that this ingredient has lots of different aliases or other names it can be used for, which is useful for importing and exporting. And it actually has multiple CAS numbers because of the multiple elementary chemicals being placed into the ingredient. And of course, because it's a buffer, you can order it from, say, Hampton Research at a varying stock pHs right here. So if I sort by stock pH here, you can see the different range of stock pHs that you can order it from, each of the part numbers. Now, one of the things that Rockmaker does is when you go to set a specific pH in one of your wells or design an experiment, you can actually choose, rather than mixing the base and acid to get your desired pH, what we do is we choose a stock of your pH, say, at a low end of your range, and a pH of your stock at the high end of your range. And then by selecting those two, we can mix up ratios of those two vials or those two stocks to get the desired pH you want in your experiment. And so if you wanted to do a very detailed grid between 5.3 and 5.4, you could do that simply by using those two ingredients and mixing up different ratios of those, and Rockmaker will do the calculations for you. And you'll notice over here that Rockmaker can do the calculations based on either a titration curve between the acid and base, which is what we do for polyprotic buffers because the math becomes crazily complex. Or for monoprotic buffers, you can just simply enter a pKa and we'll do the calculations based on that. Okay, so you've entered your ingredients. You can enter users for your system, and I'll mention that Rockmaker has full implementation of user groups and security. You can say these users are allowed to access this section of this tree or not, read-only or write privileges. Okay, so after you've entered your ingredients, you're ready to now enter different screens. Fortunately, again, Rockmaker has some major commercial crystallization screens already in here. So for example, from Hampton, from Emerald, from Jena. Did I pronounce it that time correctly, audience? And if I open a screen, for example, I can open Hampton Crystal Screen HT in our experiment designer. And when I do that, you can actually see a visualization of the screen. and I'll talk more about this a little bit later. Okay, so I've entered screens into my system, ingredients. Now I'm ready to start creating experiments. So we're creating our experiments in RockMaker. First thing we do is create a new project where we're going to create our experiments. Let's call this Formulatrix demo. Okay. And then underneath our Formulatrix demo project, and you'll notice when you create that project, you can say who the default owner is for experiments in that project, what their default imaging schedule is, etc. Under that, we're going to create what we call a protein formulation. So protein formulation is basically what's in your Eppendorf tubes when you go to create an experiment. So let's, for example, call our protein hen egg white lysozyme. And I can do things, add ingredients to it. So I'll add an ingredient, well, of course, proteins, but maybe I'd want to add compounds or ligands. And you can define your own ingredient types here. And so let's call this one, of course, hen egg white lysozyme. And I can enter the molecular weight, which we looked up the other day, which I'd forgotten, 27 kilodaltons? No, we looked it up, it was like 27?
It wasn't 35, 35 was
14?
Yeah, 14 or 27.
I think it was
Okay.
14.
Our concentration in milligrams per milliliter, and you'll notice it automatically calculates our millimolar concentration. I can also add standard ingredients. For example, if I wanted to add a buffer, and this is probably not going to work because of a bug in RockMaker, but let's say I'm going to add the bistress buffer. Oh, what do you know? Maybe that bug's been fixed. I can do that at a pH of 5.5, which actually is kind of about what lysozyme wants. And I can also attach files to that. So you'll notice actually this is a recent feature in RockMaker that people really appreciate, is our ingredient picker, where we can very quickly find ingredients. Like let's say I want to find polyethylene glycol 10K. I can just search for poly, and you can see all the different polyethylene glycols show up, and then 10K is going to be right here. Okay. Okay, so I can save this protein formulation.
Just don't look for sodium acetate as a buffer.
And so I created my protein formulation. Now I'm ready to create my first actual crystallization plate experiment. So I'll right click. I'll say create new experiment. When it does that, it's going to create a new experiment. Let me name it. So let me call this hen egg white lysozyme versus Hampton HT. So we'll run the Hampton crystal screen HT. I can choose my crystallization plate that I want to set it up in. I can choose the number of plates I want in my experiment. Set up an incubation temperature, notebook page number, some notes. And then let's actually just jump on the design. So designing a screen experiment couldn't be any easier. I just go to my screens, choose the screen I want. I just put the Hampton crystal screen right here for quick reference. And I just drag and drop it onto my, what we call this is the experiment design canvas. And you'll see when I do that, it actually visualizes the ingredients for me. And if I go to well info, if I go to, I should know this, I'm not doing it well. Okay. Yes, if I click on well, it actually shows me the color coding for my different ingredients. So salts in this case are green, precipitants are blue, and buffers are brown. So let's see, you see what's going on there. Okay. So now I have to also add a protein formulation to this crystallization plate. Again, that's very easy. I can just take that and drag and drop it on top of that, what we call layer, the screen layer, and I drag on the protein formulation layer, and that's it. And now if I go click around on my wells, I can see all the different ingredients, and I can also see protein information for each of my wells also. Okay. All right. So I can save this experiment, and when I do that, I get a new plate created under here. So I can take this, right-click on it, and I can print my barcode for it. And then, of course, since this is a screen experiment, I just take it over to my drop set or dispense it. and I put it in my imager, and because I designed it in RockMaker, the imager will automatically be told what plate type it is, and how to image it, and what schedule to image it on. Let the experiment incubate an image, and then I can come back, and I can view the images on that. And so, of course, right now, I don't have any images on that experiment, but I have this one that I've created with some images on it. Okay. And if I right-click here, I can say View Images instead of viewing the design. And when I do that, you'll see I can view thumbnails of my plate. So now a few things I can do here. I can, if I'd like to, shrink this down so I have a little bit more space. I can even actually undock it. So I can undock this. I can undock this, so I have a lot more room, and I can see things in much higher resolution. I can also zoom in to my thumbnail view. I can zoom in over here. I can double click on a well, and I can keep zooming in. The other thing I can do is I can move up and down focus levels. So if I press this F12 hotkey, you can see I can go up and down in focus. One of the things you'll notice is when I get to one of the ends, that other end there, everything became in focus. So that's our imaging system, is taking all of those slices and calculating what we call a extended focus image. It basically takes the best focus of all those individual images and shows it to you. Some other neat things I can do when I'm in the plate viewer is I can highlight things with a scribble. I can draw a ruler to measure things. And then I can also draw a box for a region. And then next time the imager goes to image this drop, it'll zoom into that region and image just that region. And note to people demoing, I didn't check this ahead of time, but you'd ideally have an image of this region, and you'd know how to get to that quickly and see it. And I'm going to fumble around if I do that, but it'll be nice. Okay, well, actually, this is an opportunity for me to show you, talk to you about support with RockMaker. So I've done something here in RockMaker that has generated a bug. And if I click details, it has all this gobbledygook on what happened internally in the program. Well, if I click Notify Formulatrix and continue, it'll ask me to type in a quick note, and I could say, hey, I was just on the plate viewer trying to show a note, and I got this exception. It'll take this exception, it'll email it to Formulatrix, we'll look into the problem, we'll fix it, and we'll get a fix over to you. And you'll actually find that our support is very proactive. You won't have to chase us down, we'll chase you down to make sure the problem's resolved. Continuing on. And so actually for people presenting, this is a very good point. Whenever you get updates to the RockMaker software, never just go give your CAN demo without testing first that you go through everything and things don't blow up. Because it's embarrassing, although I kind of recovered right there. It's embarrassing to say we have great software and then have an exception go off while you're presenting it. Okay, all right, so let me go back to our experiment view, or sorry, our plate view. And let me zoom out. I'll just fit this to the screen here. Let's say we wanted to do some scoring of these drops. There are a few ways to do that. Let's say I know that all of these drops are clear, so I can select all of those. And I need to get my scoring tool back here, so I'm just going to go down here, get this to come back, pin it back here, give myself a little extra room here, and then go to scores. And you'll notice we have different scores that you can create. One of the things that's unique about RockMaker is you can assign multiple scores to a drop. So for example, you could score it as clear and also interesting, or maybe small crystal plus interesting. So later on you could do a search for drops that have interesting in them, or maybe diffracted well, or other scores you can assign to things. Or maybe you want to be able to score things as clear and precipitate. You'd have the option to be able to do that. But I can just score all these as clear, so I'm going to click on them, and they all get scored as clear. I could have also pressed the 0 hotkey. The other option is I could just be in this view or in this view, and I can just start pressing hotkeys, so I can press precipitant, etc. And it'll automatically score it and then go back to go on to the next drop. So you can make scoring very quickly. You can see if I go through these drops, they can whiz by as fast as you need to score them. Okay. So now I've scored my plate. We can do some interesting analysis on the scores. Let me go back to the design view here. And let's say I wanted to search for all wells that were scored as crystal, or that had a particular ingredient in it. And we've added this feature, interesting, if I go to this, recently, this feature. Excuse me, sorry. That's another lesson, is always turn off your phone before you give a demo. So it doesn't interrupt you. Okay, so let's say, for example, if I want to search for all drops that are scored as crystal, or have crystal in the score. In fact, not many do. If I want to look for precipitate, then I can see all of the wells that are scored as precipitate. Let me actually go score a few more drops back as crystal. So maybe these were all crystal. And I go back to scores and score those as... That's interesting. Bug, huh?
Yeah, I've never seen that.
Oh my god. Yeah, you can scroll down.
Is it because you're not in ImageView?
So it's while you have wells selected.
Well, can you go to ImageView and see what happens? Yeah, so now the scroll bar comes.
That's a bug.
Yeah, it shouldn't happen.
It's a big bug.
I got it. I'll read down to it.
Okay. So let me select some wells to score as crystal. Yeah, and if you have practiced your presentation well, you wouldn't have these hiccups that I'm having. Okay. And so now when I go back to my well info tab and I look at the experiment design, my plate info tab I'm in, and now I search for scores of crystal, those wells that I scored as crystal showed up. And maybe I say, oh, well, that's interesting. They all have polyethylene glycol in them. Well, okay, maybe that means something. Let me actually look at all of the wells with polyethylene glycol in them and see if I can spot a trend. So you can start to do some visual analysis. But this is also useful for, let's say I want to do some optimization, search for all of my conditions that generated crystals, and I can start optimizing them. So let's say I wanted to take this guy here. So this had sodium acetate, sodium catalate, and polyethylene glycol 8K. I could take this guy. I need my tree back over here, so I'm going to bring that back. And I can just simply drag and drop it over to my project. And so this drag and drop optimization has been a very useful tool for our customers. They like it. It makes experiment design way easier. So you just drag and drop over that condition. And I'm going to create a grid layer in this experiment. And so when I do that, it automatically populates it with all of the ingredients from that condition. A question? No? Okay. Okay, and so you'll see that I have these 3 ingredients in here. So let's say I want to vary my salt concentration and my precipitate concentration. Let's say I want to vary my salt concentration along the row. Let's change that from 0.1 molar to 0.4 molar. Okay, and you probably just noticed now along the row, you can see the salt in green, that concentration increasing. Okay. Then as also, I want to vary my precipitant concentration down the column. So I can vary that then down the column. Let's say I want to vary that from 0 to 30%. And if I zoom back out, I can see that down the column, my precipitant concentration right here, I can hover over my precipitant, and it'll tell me that's polyethylene glycol, all the good information on it. Okay, so that was creating a 2-dimensional grid, and then of course I can just choose to drag and drop in my protein formulation. And I've designed a grid experiment. I can save it. I can print a barcode for it. So actually this new experiment this was the new one I created. I can name this now hit HT number, I don't know, let's say that was condition number 25 grid or 24. And I have a plate for that. I can print the barcode for that, and I can go onto my formulator or other liquid handler and automatically dispense that optimization. Pop it into my imager, get images, and repeat the cycle. Let's say I wanted to, though, actually vary all 3 ingredients and do a 3-dimensional grid. Well, I can do that also. So I can take my grid, I can resize it. I'm going to make it smaller here. Okay. And then I want to create some what we call subgrids, or multiple layers of this grid. So I'm going to right-click on it, layer tool, and say add subgrid layer. And when I do that, I'm going to put one here. I'm going to right-click on it again. I'm going to add another subgrid layer. Put it down here. And I'm actually even going to add a 4th one. Okay. And actually these two I put too far over to the right because I want to fill up the whole plate with this. So I can just drag those over. And so you'll notice it's a very visual experiment designer. And one of the things I will mention is you can create multiple layers with lots of different things in them. You can pile them on top of each other. So if you wanted to add an ingredient just half of the plate, you could, you could create one layer with a single ingredient in it that just covers half of a plate. You can do things like target the drops with layers for additives. And you can do both volumetric and concentration-based addition of these different layers. So lots of powerful things you can do with layers. But let me continue on to my 3-dimensional grid experiment. Let's say now in my 3rd dimension, I want to vary my buffer. So I'm going to change my, I'm going to go use 2 stalks for my buffer. Right now it's just coming out of 1 stock. Let's say I'm going to use my 7.4 stock from Hampton Research. And very often what you do is you have the, I'm going to choose the low stock of 5.1. Very often what you'd want to do is, and I'll go back and choose my 7.4 again. And of course you'd want to practice this so you wouldn't make that selection twice and have this disappear.
Why do you do that?
It's kind of a bug that we. So when I select that, I'm using my 5.1 stock and my 7.4 stock. So those are the 2 extreme ranges of the pH for this buffer. I'm going to do a start pH of, well, it could be anything. It could be 5.1 or it could be, let's say, 6 to, let's do 6 to 7. Let's leave it at 7.4 actually. And of course I actually can't change that 7.4 because I need to have the pH vary along. Well, we've already used the row, we always use the column, so we're going to use the layer. So here subgrid layer 1, if you look at it, has a certain pH, and then that pH changes for layer 2, changes again for layer 3, and changes again for layer 4. And you'll notice, well, what I was pointing to is this bar at the bottom shows the ratio between the low pH stock and the high pH stock. So you can get a visualization of how things are changing across the plate. And then the other thing I can do is I can expand this grid to take up the whole plate. And you'll notice the low and the high concentrations still stay the same. You just get more steps between them. And I can, if I wanted to, have multiple plates and stretch this over multiple plates. You can be very flexible in your design. So being able to resize things, drag and drop to move them, lots of flexibility, and that's my 3-dimensional grid experiment. Okay. Well, let's say you actually have a little bit more complicated situation than that. So let's say you got more than one hit, and that hit had more than 3 ingredients in it. Well, how do you go about optimizing that and looking for a solution? Well, you can go about doing multiple grids, but one of the things that happens to us inevitably is when customers have our new tools, we have an experiment type called a random experiment, and we don't take any credit for inventing it. But what random experiment does is it chooses randomly from different ingredients you give it, concentrations and pHs from ranges you choose, and it makes random conditions for you. Not a lot of science behind it, But what we found time and time again, people will come to us and say, hey, I'm so used to doing screening, gridding. I was having a protein, I was having a hard time crystallizing, and I said, oh, let me try the random experiment, and what do you know, I got all these hits out of it. And so it really is a more efficient way to work, and it lets you search in multiple dimensions and search a much larger sample space. So if I go back to my original experiment, I'll show you how you can do that. So let's say I have these conditions, all of these here that I want to optimize. So I can just control click on them to select them. Yep. I got one I didn't want. And then I can take them and I can drag them, drop them over to my project again. And I create a new experiment again. And this time, instead of creating a grid layer, I'm going to create a random layer. Okay. And when I do that, you'll notice it creates a bunch of random conditions. And let me explain to you how this is working. Actually, let me first rename this experiment to innate white lysozyme random 1, maybe. Okay. So what it does is I have some ingredient groups, and so this says, okay, for the precipitant group, always add 1 ingredient, and then always add 1 buffer, and always add 1 salt. And if I go to my group ingredients, you can see for buffer here, the buffers to choose from. So it'll randomly choose from one of those buffers. For the precipitant, here, the precipitants to choose from, and for the salt here, the salts to choose from. Okay. The other thing I can do is we have this concept called grid steps. So you can, for any given ingredient, you can change the min and max concentration. So let's say I want this salt to be able to vary between 0.05 and 0.2. Just change those endpoints a little bit. Okay. What RockMaker will do is, because the number of grid steps is set to 10, it'll choose 10 values from 0.1 to 0.2 to break that ingredient into. Okay. And actually, I'm going to go back to here. And I'm going to maybe change this to 5. And when I do that, it regenerates the experiment. And one of the things it's going to have done is, for that particular salt, sodium chloride, it'll be varying the concentration randomly between 0.1 and 0.2 to those 5 different grid steps between those. I can also do things like, let's say I want that ingredient to occur twice as commonly as other ingredients. I can change its probability. And when I do that and things update, the probability of that is twice the probability of the other ingredients in the group, which it's not, but that's a bug we know about. And let's see, another thing is, let's say I wanted this to be a little bit more like a Hampton crystal screen, which maybe only 50% of the time has a buffer, and 50% of the time has a second precipitant. Well, so I can do that by adding those groups, adding a second precipitant group, and setting that to 50%. Okay. And as you can see, it keeps regenerating my random experiment with different interesting experiments. And so it's interesting, as a random experiment really lets you randomly sample a multi-dimensional space. So you can start to do multi-dimensional, beyond 3-dimensional experiments without thinking too hard. And RockMaker, if that sample space is small, only a few ingredients with a few concentrations, you could do an exhaustive search of that sample space with random experiment. Random experiment will handle that case. And then if you have more conditions to sample that are possible to generate in the number of wells or conditions you're creating, the random experiment just does a random subsampling of those. So it's a very good tool to go from even coarse screening all the way to a very fine optimization across multiple dimensions. So, and of course, then I can save this experiment.
Precipitant, randomly chosen?
Hmm?
The precipitant that you added on there.
Yes, so if I go to this precipitant group, for example, right, if I go to group ingredients, so yes, so what this means now, this new list, is it'll say, always add 1 precipitant, 50% of the time add a buffer, always add a salt, and 50% of the time add a second precipitant.
Any precipitant.
Any precipitant. From the list of precipitants specified in here. Okay? And of course, you can add your own ingredients by dragging and dropping them from the ingredient picker. And one of the things I didn't mention, by the way, you can create favorite ingredients right here that you can very quickly drag over. And then actually, if I go back to my tree, of course, after I save that experiment, it's available. I can print a barcode. And of course, if I wanted to pipette this by hand, I can right-click here, and I can say View Ingredients, and I can zoom in here. And if you were industrious, you could print this out, and you could go through and you could randomly choose each of those ingredients, or not randomly, but you could go through, choose those ingredients, and pipette them into your plate. Of course, that's going to drive you absolutely bonkers, and I guarantee you're going to make at least 10 mistakes. And so that's where having a liquid handler helps. So you can, if you're working with a formulator, for example, take that barcode, grab your ingredients, walk over to the formulator, scan the barcode, put the ingredients on top, press dispense, and presto changeo, you have your optimization dispensed for you, and life is much easier. So some other things I'll mention while I'm in this view of our experiment. We can create different reports. So I can I can create a single drop report. So if I go back to my 2-drop IntelliPlate, and I go to, let me escape out of this filter here, and I go to my image view. I go here. Let's say I want to print out a report for this drop. I can say right-click, single drop report. And when I do that, it's going to ask me what information I want to include: protein formulation, weld condition, the images, the scores, etc. I can preview that, and it will show me what that report's going to look like. And so I could then print that in my notebook, or I can, I should know this, but there is a way to also export that, or no, that's a feature request to be able to export that report to like put it in Word or something. We don't have that. That's a request. When you're giving a presentation, don't babble like I am right now.
But you can save the images.
Yes, you can certainly save the image. And I have other reports too I can create. So if I'm back here, reports, I can do an ingredients report, which I showed you, an images report, which is basically printing all the thumbnails that can be spread across multiple pages, a plate design report, which is a design of your experiment visualized. And I can actually right-click on the tree, and I can do an experiment report, which can be a combination of all of those. You can get crazy printing out the experiment design, the well ingredients, everything, if you have to have everything documented in a notebook. So select all those things, press print, paste into your notebook, and you're happy. Okay, so I have talked about experiment design, screen experiments, viewing and scoring images, our drag and drop optimization features for creating grids and randoms. One of the things I haven't mentioned, let's say we want to create our own screens. Well, let's say we had, let's actually go back to our plate info tab. Let's go search back for drops that are scored as crystal. And I have to, this is a feature to have that applied to the image view. It doesn't, but if I go back to my design here, I can go select those crystal wells, and let's say I want to create a screen out of those and run these against my protein every time. So I can do that, drag and drop them into my super screen that I'm creating. And when I do that, I can create a condition list layer, which is what we call basically a screen layer. This is what you do for a deep well block, but it's a list of conditions, a list of ingredients to have in each condition. And when I do that, it creates that condition list layer for me. I can actually go to a bunch of different experiments and drag and drop my favorite conditions into this and create my own favorite screen that I like. And then, of course, you could go to your liquid handler and you could dispense that from RockMaker. Okay, so I've shown you some searching within the experiment designer, the plate viewer. Let me also show you some more advanced searching that you can apply across your tree or all of your folders of RockMaker. So here I can, for example, look up drops by score. So I want to look for all drops with a hotkey greater than 5. So let's say our hotkeys, the higher the hotkey, the better the score. So I'm looking for better than score 5. Let's say I want to search in my sample plates path of the tree. So you can just choose a single path of the tree or the whole tree to search. It'll search from that level below. Very, very nice feature. I can choose the fields that I want to display in my search result and my search constraints, which can be multiple level ands and ors. And if I run a search now, it shows me all of my different drops with the protein that's in them, name of the experiment, and ingredient names, and I can keep scrolling over, all different information from that. Now I can take this information if I wanted to, I can right click on it, and I can export it. So not only is this a search tool, but it can be a data export tool, and you can export this information to Excel and do further analysis in it. I can also double click on this, and it'll actually take me to my plate viewer, and hey, could you report this as a bug? When you double click and the experiment is already open, it doesn't take you to the image view with the well highlighted when you double click from a search result. Okay. So when I double click, it should, bug. It doesn't do that in any view. It should actually take you to that drop and have it highlighted.
In the image.
And actually it should probably just go to that particular drop or well.
It doesn't do that at all.
It doesn't do that right now. Yep. So the double clicking from search results doesn't work properly. And it used to do that in previous versions of RockMaker. Okay. So one neat thing about searches is I can actually create my own searches. So I can right click, say new search, define the fields I want, define my search constraints, and you can save those searches and you can keep reusing them and build new ones. And all users in RockMaker see all of those searches. So we have some searches in there, but you can create your own. Okay. I'll just mention quickly that to show sort of the maturity of RockMaker. So of course you're going to be imaging all these plates and creating all these images, and after a while you're going to fill up your image store. So RockMaker has a tool called Image Management, which lets you intelligently go through and delete old images. For example, you can create different searches to find those images. Just like the search tool I told you, you can drag in branches of the tree where you want to apply this image management. You can say, okay, for this branch of the tree, anything that's not scored as crystal, delete all the images. Anything scored as crystal, just save the one extended focus level image, and zoop, it'll shrink down your image store usage. You can also see how much image storage space you're using. So I can right click on here, for example, and I can say display storage usage, and it'll calculate all of the amount of storage used by the different folders. Useful to go and hunt down the user that's hogging all of the storage in your image store. I've already mentioned reports, I've already mentioned user groups and security. That is it. That is RockMaker.